Okay, good afternoon, everyone. This is Heidi Kurtz of the National Association of Energy Service Companies. Welcome to our second webinar in a two-part series. The first one was last week on air quality and indoor air quality, and today we are talking about lighting and water technologies. I wanted to first thank LFE Protect for sponsoring today's webinar and last week. LFE Protect provides an extensive array of health and safety solutions to help protect your people, property, and business. These products utilize a wide variety of sophisticated technologies to sanitize and disinfect your environment and promote health and wellness for employees and customers. We will be recording this session, and I will send links to the recording and to the presentation to everyone who's registered, whether you attend today or not. And those will be available probably Wednesday. And there is one CEU available for this webinar, and you can contact my colleague Nina Kogan on the slide here for the proper documentation for that. We're going to start out with our speakers and then do Q&A at the end of the webinar. There's a place where you can enter your questions, and we will get to as many as possible. We have a lot to discuss today, so I will introduce our speakers. Our first speaker is Frank. You have to tell me how you say your last name.
Agraz.
That's what I was going to say, but I should have asked you that 5 minutes ago. Thank you. Frank Agraz joined Eco Engineering in 2019 and serves as Senior Director of Strategic Initiatives. He is responsible for improving the customer experience by enhancing the company's process and raising awareness of eco engineering as a leading design build lighting engineering firm. He is lighting certified by the NCQLP and is currently its exam committee chair. He also serves on the society board at large as at-large director for the Illuminating Engineering Society. And our second speaker today is Paul Bassett. Paul is vice president and co-founder of Water Savers, a recognized leader in advanced design and construction of water efficiency projects all over the United States. Paul brings over 30 years of experience in all facets of managing water efficiency projects, from investment grade audits, advanced design of solutions, scope development, measure implementation, and measurement and verification. I will now hand the controls over to Frank to get us started right now. Okay, I think you're good, Frank.
I see it moving. Thank you. Let me see if I can click here and if it will move for me. There we go. So, hello everyone. I appreciate you taking time out to join us today. Today we're going to explore how electromagnetic radiation can kill germs and inactivate viruses. Basically, we're talking about UVC and visible light disinfection. As we all know, what we call light is one small region within the electromagnetic spectrum. I wanted to show the two areas of the spectrum that we're going to be focusing on today. One of them is within the visible portion of the spectrum, and the shorter bluish content of the spectrum that's the visible light. This is the 405 nanometers. The other area is in the ultraviolet range, and more specifically the UVC range. One of the things I wanted to point out here is as we move to the shorter wavelengths of the spectrum, the wavelengths get shorter and they get smaller and closer together. And one of the effects of that is that the energy within each photon gets stronger. So it's no coincidence that as we move toward the ultraviolet spectrum, there is quite a bit of energy to kill bacteria and viruses. We're going to break this up into two pieces here. Many of us may have heard of UVC, and the benefits of UVC is that it does kill both bacteria and viruses. The predominant wavelength is in that 254 nanometer area, and unfortunately, it is not safe to use when humans are present. So there are some constraints about when we want to use that. On the other side is visible, which operates in that 405 nanometer range. It is safe to use around humans, and it does kill bacteria, but however, it is not effective against viruses. So it is a little bit of a hit or miss with respect to which technology you use. Let's focus first on the visible light side of it. One thing that should be set up front is that this is not an instant kill type of situation. Most areas and applications that use visible light are in a continuous operation. And actually it takes typically 4 to 6 weeks to dramatically lower the bacteria levels. Now that being said, if it can be used when people are around and using the space, there's 2 different types of applications that we see. One of them is having that 405 nanometers energized, as well as the white ambient light, kind of referred to as cleaning with white. There's also a more intense cleaning, which is more of the clean only mode. And basically the white light is shut off, 405 nanometers kick in, and it does speed up the killing process. Now, like I said earlier, visible light disinfection only attacks bacteria. So when we talk about, quote unquote germs, what we're really talking about is gram-positive and negative bacteria, yeast, and fungi. You may have heard of other terms like MRSA, E. coli, Listeria, Salmonella. These are all of the things that this visible light will kill. Some of you may have seen, as you walk into a hospital, there may be a wall-mounted unit close to the ceiling, and it kind of gives off that purplish light, and it's just there. So that's what visible light helps to do. Now this is this kind of slide helps to point out the effectiveness of visible light disinfection. The graph on the left shows a typical bacteria growth using typical cleaning procedures. And what will happen is over time, the bacteria will grow and grow, and then it gets cleaned and it drops down to 0. And then the process repeats. The problem is bacteria will typically grow faster than what that cleaning schedule allows. And so you have a fairly high bacteria level at any given time. With visual light disinfection, the impact of that is, over time, not only are you maintaining your current cleaning schedule, but the light itself is reducing the overall levels. So over time, you do have a reduction. It is not typically killing 100% all the time. It's a reduction. And so that's kind of an important thing to note, is you're not going to get all of it all the time. So to kind of summarize visible light, it is a supplemental method in addition to your normal cleaning schedule. And think of it as contributing to the best practice within your infection control. And it is not designed to replace a current method of cleaning. Let's change gears to ultraviolet in that side of the spectrum. I wanted to show you kind of a blow-up version of the spectrum here, and to see that ultraviolet can be broken down into what's called UVA, B, C, and even vacuum ultraviolet. And this is all depending on the types of spectrum that are in place. When we talk about the different categories of ultraviolet, think of UVA as the type of light that's emitted in insect traps. With respect to killing viruses and bacteria, it is 1,000 times less effective than UVC. So you're not going to see too many of this type of nanometers for killing viruses. UVB is that wavelength that's most associated with getting sunburned, getting skin cancer. It does penetrate the skin more deeply and does have more energy, but it does have limited effect as far as disinfection. UVC, that's really what we're talking about here. As we said earlier, it's not really safe for humans to be around it. And if you are exposed to UVC, you can get what's called welder's flash, also skin redness. And although those are both temporary conditions, they are very painful and not recommended. There's another type of UVC that is still being researched. It's kind of in its early stages of adoption, called far UVC. It uses excimer lamps and then some types of LED, and it is getting to that point, but really it's still being researched for future use. If you take a look at this graph here, you'll see the actual effectiveness on disinfecting using UVC based on the wavelength. And you can see this one line here. You heard me talk about 254 nanometers. The reason why that wavelength got pegged is because of one of the light sources that is most common, which is low pressure mercury. And that gives off a lot of 254. And from the industry manufacturing perspective, that was the wavelength that was a little easier to manufacture and to output. So that's why you kind of see that 254 on the graph. As far as UV lamp types, amazingly, LED is not the technology of choice in this particular field. As I said earlier, low pressure mercury has been the champ of this type of light. And actually, it's been around since the 1930s. There's also xenon arc, which offers continuous and pulsed operation. It is a little more expensive. It is another type, and some companies do offer that technology as well. Looking ahead, we do have this halogen excimer and LED. They are up and coming. However, they don't really have the effectiveness of the mercury and the xenon arc. So a little bit about some terminology that you may have heard of. I just wanted to clear up a couple things. You may have heard of germicidal UV or GUV, and that basically just talks about the fact that we're using ultraviolet radiant energy, and it does kill both bacteria and inactivating viruses. You've heard me go back and forth a little between the word kill and inactivate. I wanted you to pay attention to that because in reality, viruses are inactivated, they are not killed. Because viruses aren't technically alive, they can't be killed, for those who want to know. But what the UVC light does is it interacts with the RNA and DNA molecules. And what we're really doing is we're rendering them non-infectious, so they cannot recreate. And so that is how a virus gets inactivated. When we're talking about disinfection, one of the terms that you'll hear is the kill rate. And when you talk about how these bacteria or viruses are neutralized, it's basically on a logarithmic scale. So when we say we have a 1 log kill, we're talking about removing 90%. To go to a 2 log kill, we have to go to 99%. 3 log kill is 99.9, and so on and so forth. In order to achieve these kill rates, though, you basically have to double either the time or intensity to achieve that next level of kill. So it does take quite a bit to go from 90 to 99% and so on. When we take a look at UVC light killing and inactivating, there's a lot of factors that affect that process. I wish it was a lot more simple than this, but really it depends on many, many factors. The type of pathogen, the environment that the pathogen is in. Is it on the surface? Is it in a particle? Is it in aerosol form? What's the distance from the light source to the actual particles themselves? What's the light source wavelength? How intense is the light source? And also, what other materials are in the room that could affect the kill rate? For those who are looking for a quick cheat sheet, it's like I said earlier, it's not as simple as saying if you turn on this light for 30 seconds or 5 minutes or 3 hours, you're going to kill the virus. Really, it's a function of dosage. And so when we take a look at dosage, it's really the intensity of that UV source multiplied times the time. I'm showing you an energy dosage chart here in order to achieve a 1 log reduction of 90%. So if you see this particular spore that I have circled, you would first have to find out what is the microwatts per centimeter squared energy rate at 1 foot. So if that lamp has an 800 microwatts per centimeter squared value, you would take this energy dosage divided by the power, and when you do the math, it's going to take 14.5 seconds with that light source at 1 foot away to kill this type of bacteria. So, kind of do the math, it does get a little more complicated, unfortunately. So there is no one single answer. Luckily, there are some folks who have tried to make the process a little bit easier. What you're looking at here is a UVC dose indicator. It's basically a dosimeter that will change temperature once you've achieved a lethal dosage of light for a specific type of bacteria. This particular one is calibrated for MRSA. And so if you were to turn light on a room, the UVC light, you put this little placard on whatever surface, and once this turns orange, you know that it's received enough dose to kill that particular bacteria. One of the things that's been on all of our minds lately is COVID-19. And COVID-19 is a virus, UVC. There had been some questions early on, does UVC actually inactivate the COVID virus? What you're seeing here in an initial study from Lisa, which is one of the institutes that we have on the East Coast, they did some initial studies to show that yes, UVC does kill the SARS-CoV-2 virus. However, it depends on where that virus is located. On the left, you can see the virus within human serum, which is, think of it as blood without the red and white blood cells. And even if you leave the light on for 60 minutes within that human serum, it's not very effective. However, that same virus that happens to be in an aerosol from, let's say, you coughing or sneezing, for the same dosage, after 15 minutes, it gets inactivated rather quickly. So again, it is a little bit more of a complicated situation, but the good news is that UVC is effective depending on all those other factors we described. One of the things we want to take a look at is where is UVC technology being applied? There's 3 major areas. We can use UV in an upper room environment. We can use it as a mobile unit, and we can also use it within air handling units. Disinfecting room air with DUV is effective when you have a light source that is out of the range of people being able to see the light source, and it also requires that you do have quite a bit of mixed air and HVAC ventilation. So this is one way to effectively disinfect the air within the room. Another way is to take the light source to the room and disinfect surfaces. You can disinfect masks and instruments. Again, here it really depends on the dosage and how long are we going to be able to leave this light in the room to wipe out all of the surfaces within that area. We can also use UVC within air handling units. This does have a certain effect. However, the much better way to do it is by having the light source in the room that's being disinfected. So there are some good things here. It just It really depends on what you're trying to achieve. Just so you know, there is some regulation that's starting to pop up. Here are some of the associations that are working on trying to keep us safe. Unfortunately, there are some manufacturers who are marketing UVA products as being, they're being sold as germicidal. You also have some UVC products that are being sold on Amazon.com as an example, as a handheld wand, which is not very smart if you're going to turn around and stare at it. So definitely some safety issues. So just know that we are working on trying to regulate the community on keeping us safe with UVC. I'm at my 20 minutes. Thank you much for your time, and I look forward to your questions at the end of the presentation.
Okay, Paul, just want to make sure you have access to the mouse now. There you go.
Looks like I got it. Frank, very good. Actually, I would have incorporated some of your stuff into mine, knowing that those lights do a lot of work inside of spaces. I'm going to give you a disclaimer. I'm not a doctor, or I do not work for the CDC. So all the things I'm going to be talking to you folks today is within our experience and research that we've done. Our company ideally focuses on water efficiency, primarily in the ESCO space. Certainly this new world we're living in is going to affect the way we do our business and how we calculate our costs and savings. So these are the items we're going to be kind of going over today. Ideally, we wanted to talk somewhat about how this impacts the current realm, but we also want to talk about how we do establish water consumption within buildings and how that affects our costs and paybacks. There's some new tools that we've been able to integrate into our analysis to be able to fine-tune how much water is being moved through a building. What are the different methods we're going to be able to identify and hopefully reduce some of the spread of viruses within bathrooms, and then how these new devices and their flows within them are going to affect our ability to sustain the bathroom water consumption. So the first thing we do when we analyze a facility is try to determine where all the water is going, what devices are using what water, how much of that water overall is being consumed based upon our utility bill analysis. So you can see on this particular facility, 34% of the water being consumed is within the toilets, and that's based upon how many folks are bodies to potties, as we say. Everything else through lowers mechanical consumption. And the key here is trying to determine every percent of water and where it's going. And if there's some miscellaneous and unaccounted for water, we want to try to identify that in a full analysis. So in this particular project, it looks like just the preliminary assessment is a 28% savings. And it's important really to be able to do a full water balance, because it gives the client the ability to understand where his water's going, or her, and our folks the ability to put together a proper project to be able to identify those areas where all the water's going, so we can reduce those percentages and still maintain the mission. And the water utility analysis is critical too, especially now that we have a lot of buildings that their personnel are being reduced. Because what happens is in water, unlike some of the other ECMs, the consumption is based on the humans that are using the water. So in this particular slide here, where we have it, the total of full-time equivalent occupants, this number here will be going down during our COVID analysis. So you're also going to see within those particular months of analysis that their water consumption is going to go down significantly. not so much, I'm thinking that the HVAC, because you still need to maintain the building levels, but our water consumption is going to be going down tremendously based upon the offices, whether they're vacant, whether they're reducing their load, or their personnel, until hopefully this comes back to the normal. I don't know what the new normal is going to be, but it's definitely going to affect our ability to analyze our projects and get our paybacks where they used to be before the folks were in there. So how do we now use the new tools that we're given to analyze the water consumption? Well, some of the newer tools that we have now are similar to what they're using in the energy side, where we can now put some devices on the water system and track and trend how much water is being used almost minute by minute. Where in the past, we would get a water bill once a month or once a quarter, and it didn't really give us the profile of how that water was moving within that facility or their building. So one of the newer tools that we have in our toolbox is this. It's a cloning device where it allows us to put the stethoscope type tool onto the register of a positive displacement meter and clone the magnets that are spinning inside of that register. And then we can convert that over to a signal, and then we can calibrate that to match the exact flow rate of that water meter, and then transmit that information up into the cloud, where we now have the ability to track and trend that information and provide reports. Another tool that we have, if we do not have access to the water meter and we can't cut in the line and the pipe, we have the ability to put on this ultrasonic strap-on meter, which will do the same thing as the clone meter. Now we can configure this device to the actual flow rate going through the pipe, and then we can use that information and transmit it remotely using that cellular modem, and that information goes to the cloud. So these are really good tools that allow us to almost immediately understand where and how that water is moving through that building or that system, whether it's the whole building on the main service, or we can put it on the cooling systems, irrigation systems, anywhere we have a sub line that we can track and trend that data and that information. And then the data is really valuable, especially the reports that are being able to produce within this information. And some of the key points is when we started deploying these devices, you can start looking at the water usage when the building isn't supposed to be occupied, when there's no personnel in there, and see what's happening at 2 and 3 in the morning and get an idea if we have some leaks within the system. And in this particular report down here, if I'm looking at a 3 a.m. every day in a facility where I have no mechanical equipment being used, and I have a leak at 3 a.m. at 10,000 gallons an hour, that's going to tell me that we need to go find where the problem is, because it's consuming tremendous amounts of water at times that it shouldn't be using any. And this will just give you a heat map, somewhat of being able to quick snapshot of analyzing the data and the water, what times of the day and night that water is being moving through that particular facility. This particular building, or actually military base, there was significant leaks in the water system that we were able to identify and capture in scope. Back in the bathroom. So as we were putting together this particular training for NAESCO, you start really realizing just how many things that you touch in this bathroom or a bathroom during the short time that you're in there. Not including if you're a female and you have a pocketbook and you sat on the floor and you touch that, or if you're touching your cell phone and you touch something else, or if you, God forbid, you're touching your face. So you can see here, there's a lot of things that we as humans, if it's a system that doesn't have any sensors or automated, that you need to touch as you proceed your way through doing your business. So we're going to try to look at things at how we can integrate newer automatic devices so we don't have to touch anything with our hands while we're moving through the bathrooms. And as I was doing the research here and almost logically going around outside now, our biggest risk isn't what's going on inside the bathroom. It's what's happening on your way in, and you're standing around waiting for the restroom to be available. So this is really where you need to, make your caution when you're in large crowds or you're within a space where there's folks waiting in the line. Try to stay cautious as you're going into the restroom. So there are some advances in plumbing and plumbing control systems that allow the building manager to be able to control, access, monitor the devices within the bathroom, and even allow the manager to even tune the flushing volumes of these devices so we can maintain savings. So some of the advanced controls that are within the bathroom now that have of this wireless technology that gives us a bunch of information that we can make critical decisions upon based upon the water consumption and the personnel and how often the folks are within the bathroom. So these new tools will actually tell us how many folks were within that bathroom at any given point in time. So you can manage and monitor that, so you can ensure that you're trying to space out how often someone is within the bathroom. So you can put, once you know there's more folks that need to be going to the bathroom than should be, you can start putting up signs or even more control points to be able to slow the amount of people within the bathroom, especially if you want to have a disinfection period. So say if you wanted to disinfect the bathroom after so many personnel went through, these newer tools allow you to pull that data, look at how many folks were within that particular bathroom in a given minute, hour, or day, and then you can establish your disinfection protocol behind this information. I'm sure most of you have read the news, or you're seeing on the news there's a new term-ish, I guess, based upon the COVID, that toilets now produce a plume of water and air because the fact that we don't have lids on our toilets, and so when we flush the toilet, these droplets supposedly are spraying within the air. So to lid or not to lid? So typically what we found in our business and in public restrooms, we are not putting lids on toilets. Residentially, we do, and the reason behind the no lid, there's a lot of them, but one of them is really the cost of these devices and how frequently they would be damaged. At least that was historically the case. But if you flush a toilet with fecal matter or waste in it without a lid, they're saying it generates this plume, which then contaminate the air within the bathroom. So some of us know that there is a technology out there with vacuum toilets. They're in airplanes and some of marine, but they all have moved also into the prison system to be able to manage waste better and more effectively. And these systems, from what they say, they draw the air and plumbing down, and they don't create an aerosol. Oops, sorry about that. So what does that look like? They have vacuum pumps and tanks, remote, that connected to the waste lines of the system, and they control the waste using pressure and air and some water, and these systems use less water than a typical domestic plumbing system. It says 68%. So another item that can affect our ability to maintain our health and hygiene within the bathroom is the faucet. In our previous, before COVID, we would try to look at the faucets and reduce the water within the faucet down to a half a gallon so we can reduce the consumption. The trend probably is going to go more towards the laminar stream, 1.0 gallon, which is required in all healthcare facilities where there's no mixing of water and or air. The lowest flow on that particular device is at a 1 gallon, where we would typically have used the stream spray in our water conservation projects down to a 0.5. But we're probably gonna see more going to the laminar flow, which will probably increase some of the water, but it'll maintain hopefully more of the hygiene within the restrooms. Certainly going to see a big move towards automatic sensors, automatic faucets, automatic soap dispensers. While they don't typically, if you had a manual faucet, save water, they're definitely way better for maintaining hygiene within the bathroom itself. There are a little bit more maintenance included in these devices because they need to be cleaned and maintained properly, but they will definitely help with maintaining hygiene. Hands dryers, there's been a lot of speculation about them lately. I did a research preparing for this. While the World Health Organization is saying hand dryers are not effective with coronavirus or killing the virus, they may also assist in spreading it potentially within the restroom. So the World Health Organization is recommending that we use paper towels. One of the bigger elements trying to get into the bathroom is the door. Whether you got to touch it with your hand or you got to push it in or pull it out, there's probably going to be a movement similar to what they have in the airports, where they're going to remove the main door and have you pass through without visibility to the outside public. Or we'll have to put in retrofit automatic doors to access the restroom that are hands-free. So again, there's the trend to replace any of the devices within the restrooms to automatic sensors with touch-free. We're starting to see a lot more of that occur, especially within the latest proposals that we've been submitting to our customers, the higher request of these solutions being integrated into our projects. I do want to thank everyone for attending today, and I know Heidi's going to open it up to questions here. So thanks again.
Thank you very much. I don't know about you all, but that was a little bit scary. Let me get to the questions here. All right. Bear with me 1 second. All right, this may seem like an odd question, but it has been asked of us. What do you do in a classroom where many times you will have living animals like fish, rabbits and guinea pigs and things? Do these all need to be removed during a clean? And but that would defeat the purpose of regular automatic cleanings. I think this is for Frank.
So that's a great question. I don't know. I don't have a specific answer at this point. I would need to do some research, but knowing how other animal ocular systems work versus humans. I can't tell you whether UVC is going to be safe for the eyes of a rabbit or a frog or other creature. I think common sense would say you need to remove every living thing out of the space, to be safe. Now, that being said, I know that there's a lot of research being done on the materials themselves. We're talking plastics, metals, fabrics. If this UVC cleaning is going to become a more of a standard type of feature in our spaces, we as architects and designers and interior decorators are going to need to better understand how UVC interacts with these materials. So UVC does break down certain materials within a room. So it's not just people we have to look out for, but the actual materials themselves.
Another one for you, Frank. I assume that GUV is an application of UVC. Please explain.
Yeah, forgive me for not explaining that better earlier. GUV is just simply more of a generic term that encompasses all of the bands of UV. So UVC is bound by a very specific wavelength range. Germicidal UV refers to all of it in all bands of the spectrum. So GUV is generic, and the umbrella UVC is a specific application based on that 254 nanometers.
And then have you installed UVC in packaged rooftop units, and can it be done effectively?
I'm not an HVAC expert. I would imagine that there are some areas where they can put UVC within the air handlers, as you saw in one of my photos. But as far as more specific to that, I'm afraid I can't answer that HVAC side of it.
All right, I have a question for Paul. What percentage of your restroom retrofit projects are resulting in 100% touchless installations? Is it a standard approach, or is it, is it not being used that much yet?
Yeah, I wouldn't say it's a standard approach yet, because of the slowdown with development currently. But we have seen an uptick of our projects that are in current development asking us for adults to move forward. If it's a manual to a manual retrofit, going from a manual flush to an automatic sensor, I would say we're probably seeing about 50% of the projects are requesting this additional sensorless application. Unfortunately, going to this sensor or the sensors from a manual is an increase in cost without any attributed water savings to it, so it doesn't provide any positive cash flow.
Okay. Sorry, I'm jumping around here. I just figured out how to open the question thing so I could actually see it better. My apologies. This is for Frank. Has COVID-19 been tested under UVC by anyone yet?
Yes, actually, the one of the very last slides I showed was some studies, preliminary studies done by a lighting institution on the East Coast, and they have shown that COVID-19, which is the SARS-CoV-2 virus, is susceptible to UVC. So UVC will kill it. They're probably coming up with the exact dosage required, as you had seen on that other slide with all the different dosage values for a 1 log kill. So like I said, it is a little more complicated, but yeah, the COVID is not a, super bug that can't be killed. It's just like any other virus. We just need to know the exact dosage to get the job done.
Okay. Paul, to realize that we've had the toilet plume in restrooms for forever, is there any evidence that this is really spreading disease such as the coronavirus?
No, they're still testing, this in labs all over the place, all over the world right now. It's still inconclusive, but the tests have been coming back that they are showing that the toilets without a lid on them are aerosoling the water within them. Whether or not it can actually carry the virus and maintain it in the air, that's still to be determined. But they are saying that it is better if you're going to flush the toilet and stand next to it or be within the room, that you should flush it with a lid. That's the recommendation.
Okay. Frank, UV applications for home use have been common for some time. Will those units do anything for coronavirus?
Yes, so UVC is effective against COVID-19. Unless you have a dosimeter to make sure that you're getting enough of the energy to the surfaces and spaces. That's something that you would probably want to work with the manufacturer to get their recommendation for their device, seeing as every instrument has a different intensity of the 254 nanometers. So you would need to get the recipe, as it were, from the manufacturer. It can work, but again, I highly caution anybody to go and buy a kind of an off-the-shelf unit. I have seen some advertisements and some things where they put what looks like a fluorescent high bay on wheels, and you plug it in your wall and you roll it around and turn it on, and it just goes to town. I highly advise that you work with a manufacturer to make sure that we're using the product in a manner intended by the manufacturer. But yes, it will work.
And this is a comment made that you could answer or comment on, Frank. IES white paper says induct units have significantly less effect than uplight. Uplight is equivalent to 27 turns of air per hour versus 2 turns per hour in induct units.
That's absolutely correct. Having the light source in the room in which is being disinfected is much more effective, much better than putting lamps in a on the HVAC side of it, because it has to travel so far before it actually gets into the room. So yeah, that's absolutely right. I did use that IES document for part of my research, so I'm familiar with what they're talking about, and that's a true statement.
Okay, and have you installed upper room air UV systems for air treatment?
I have not personally been involved with the company that has installed that. I've done plenty of surveys and audits, and I'm familiar with them being in place, but I have not personally installed them. I will say, based on what we know about UVC and how it works, again to repeat, putting those systems in the room that you're trying to disinfect is the most effective way to do it.
And Paul, someone was wondering if anyone has thought of hooking up a motion sensor to the door of a bathroom stall that when the door opens, the toilet flushes.
That's a very good suggestion. I can't say that I have had that yet, but I'm imagining there's a couple of manufacturers out there that could or would take that into account. setting up their wireless program. So very good suggestion, whoever that was.
Yes, that was a woman named Caitlin Elyard. Seems like a good idea to me too.
For sure.
And then someone said, at a minimum, I'd be happy to add the phrases bodies to potties and to lid or not to lid to my ESCO vernacular.
Well, I
Yeah,
can't
I think that one's
claim
gonna stick.
I can't claim the bodies to potties. I think Francis Wheeler was the one that that either coined that one somewhere along the lines. The lid to lid was one that I came up with this during my research. So yes, thank you.
All right. Well, I think that's it for questions for now. But when I share the presentation and recording with all of you, just keep in mind the presenter's slides with their contact information are included. And if you have a more immediate question or need to contact someone, you can always email me, which is heidi.kurtz@nasco.org. So thanks again to Paul and Frank. It was great. And I guess we'll just keep on learning as we go along in this new day and age.
Thanks, everyone. Thanks, Heidi and Frank.
Yeah, thank you. That was good stuff. I appreciate it.
Bye, all.